Hi, in this video, we'll be mainly covering the second notebook. And this video is actually split it into few different parts because the content is quite heavy. So this note covers three important aspects. How do we load data from GitHub? And we'll be discussing about pandas, and NumPy modules to let you know that for the data science activities, these packages are very widely used. Okay. Also, we'll be learning few standard tools about data visualization. So in this part, we'll be learning about two very popular packages. One is called matplotlib and the other one is Seaborn. Okay. So at the end of this lecture, you should be able to answer questions like how many rows and columns are there in a database or data frame or table, and what are the different data types? Are there any missing values in any columns? How will you deal with those missing values? Can you summarize some features and the data as a whole? Are all these data trustworthy, or is there any outlier in the data? Okay. And finally, is there any association among features? We are importing here pandas, NumPy as NP, Seaborn as SNS, and matplotlib dot pyplot as PALT. So one thing I forgot to mention that we'll be answering all these questions for a specific data set, what we call automobile data. But the same is applicable for any other tabular form data set. So the content that we'll be learning, you can apply to many other data sets. So the data set is uploaded on my Git repo. So you just need to run these two lines to load the data. Okay. So if you look at the data in CSV file format, and the CSV file, you can think it as a table, and then once it is loaded in the pandas vocabulary, we are calling it as a data frame. Okay. So that's why we call it DF. Okay. So this data frame has almost about 12,000 rows and 16 columns. Okay. Here, just like in Unix command, we are printing the first two rows by df.head, and you can see that they are talking about make, model, year, then engine fuel type, engine horsepower, engine cylinder, transmission type, driven wheels, number of doors, market category, vehicle size, style, highway mile per gallon, city mile per gallon, popularity, and this is the retail price. Okay. So this is actually showing the first two rows of that table or data frame, but you can use a transpose operator. So we're showing the first two rows and then we are transposing just like a matrix transpose operator. Just like the head operator, you can also run the tail operator. Will give you the last two rows of the data frame. And on operation you will do quite frequently is you want to look at what are the data types. You as an independent reviewer or manipulator of any data, you have to look at the data and figure out that what are the types are. But you can also take advantage of this method to look at what are the different data types the data frame has identified for each column. So you can see that you have the make, the first column to be an object type, and then the second column is an object type, and then year is integer type. So we are seeing a few different types. One is the object, and then integer, then floating point. So we can quickly connect that the integer and floating point numbers are actually numeric. There is another data type we are referring to what we call object, and here we'll take a little bit time to understand because I put some red text here. If I am saying that careful when you find a column with object data type, So object data type can mean a lot of things that we'll learn moving forward. But in summary, you can quickly connect that these columns were string data type or categorical data type, but Panda is actually referring these to be an object data type, you know. So you might think that, okay, they are referring the string data type and object, or maybe the categorical data as your object, but that's not really the case, because Pandas has, or Python has, well-defined string and categorical data type, you know. So when Pandas is referring a column data type to the object, you might have the same kind of data, or you might have some mixed data. You don't expect in one of your table column you will have a different format of data. When Pandas is actually showing you that, okay, this is an object data type, then it is up to you to verify whether the data are of same type or not, you know. Now let's convince ourselves that when we have an object data type, we have to investigate a little bit more, and to let you guys know that the object data type takes more memory than categorical or string type. Okay, so now you have a data frame, and you have a different way to locate or access your columns, you know. So here we are looking at the make column. You can either just put a def dot make, so that will show you that particular column, or you can also access this way, you know, just put a third bracket and put the column name, you know, you will get the same results. Okay, now we want to find that how many unique values are in that column, you know, or what are the unique values. So recall that we have around 12,000 records, but if you just execute the unique method, then you will find all the unique values within that column, you know. So you have BMW, you have Honda, you know, so these are the unique values within that column, you know. So this is the entire list, but if you run just n unique, then you will find how many unique values are within that column, you know. Let's run the dot column. So this will show you the columns of your table, but if you I'm just calling the len function, will give you what is the length of that list, you know. We have talked about how to access one column, how to get the unique values within the column, how to get how many number of unique values within a column, and we have also seen how to see the number of elements within a list, you know. Now I will be describing one Pandas method, which is called describe. Okay, so when I call df.describe, it returns me one data frame, you know. It has its table headers and there are some rows, so definitely this is a data frame. But if I first print the shape of the data frame, I will find that the shape is actually 8 by 8. So this is an 8 rows and 8 column data frame. So what does that mean? So here, when we call the describe method, it returns me a summary data frame, and its shape is 8 by 8. So there are 8 rows and 8 columns. This is how the data frame look like. So we can say that, okay, in each row we have some statistics, like how many records were, and then what is the mean, standard deviation, minimum value, 25th percentile, 50th percentile, and 75th percentile, you know, and the maximum value. So these are the 8 summary statistics we got, but just take a little time. Our original data frame was 11,000 by 12, I guess. Let's look at df save. So this was 12,000 by 16, you know. So here we got a data frame with 8 by 8. So we are not getting the statistics for all the 16 column, rather we are getting statistics for 8 column, you know. So the message is that you will get the summary statistics for those columns where Pandas identify those as numeric, either floating point or integer, you know. So here if I count, we have 16 columns, and 8 of those columns were identified as numeric data columns. So the summary statistics are for those columns. So let's have a little bit understanding of the values of these columns. Let's focus on this column, highway mile per gallon, and you can see that the mean is 26.6 mile per gallon, and the standard deviation is this value, and then maximum is 354 mile per gallon. So this looks to be natural, but if you look at statistics for number of doors, because number of doors are actually integer values. So if you have mean 3.43, so it is up to you who will decide that whether these statistics for integer values make sense or not. So this concludes my first part.